There is a position so familiar, so embedded in the texture of modern daily life that most people never think of it as a choice. They simply arrive in it. The alarm goes off, the morning routine unfolds, and within an hour or two, the body has settled into the shape it will hold for most of the next 10 or 12 hours. Seated at a desk, seated in a car, seated on a couch. The posture is passive, the demands are minimal, and the body accommodates without complaint, at least at first, at least in ways that are immediately noticeable. The complaints come later, and they come quietly, and they come in a language that most people spend years misinterpreting. Because the body was not built for this. That statement sounds simple, almost obvious, but its implications are far more serious and far more specific than most people have ever been allowed to understand. The human body is the product of millions of years of evolutionary pressure that selected relentlessly for movement, not for exercise in the modern sense, not for structured workouts or timed intervals, but for continuous, varied, low-level physical activity distributed throughout every waking hour. The skeleton, the cardiovascular system, the lymphatic system, the metabolic machinery, the spinal architecture, the neuromuscular system, all of it was designed around the assumption that the body would be moving, more or less constantly, for most of the day. Sitting still for hours at a time is not a neutral activity. It is a biological mismatch, and the body registers that mismatch in ways that begin within the first 30 minutes and accumulate quietly and persistently into some of the most serious health consequences associated with modern life. So let us go through exactly what happens, not in general terms, not in vague warnings about being sedentary. Let us follow the body through what actually occurs, system by system, from the first hour of interrupted sitting all the way through the long-term damage that builds in people who spend most of their waking lives in a chair. The first thing to understand is that the moment you sit down, a switch is flipped in your metabolic machinery that has immediate and measurable consequences. Skeletal muscle is the largest metabolic tissue in the body, and it is responsible for the majority of glucose uptake from the bloodstream following a meal. Muscle tissue does this through a mechanism that is partly insulin-dependent and partly driven simply by muscle contraction itself. When muscles are contracting, even at low levels, they pull glucose out of the blood and use it for fuel. This process runs continuously during movement and keeps blood sugar levels stable and insulin demand low. The moment those muscles stop contracting, the moment you sit down and the large muscles of the legs, the glutes, and the core go quiet, this glucose uptake drops dramatically. Within 30 minutes of sitting, insulin-independent glucose uptake in the leg muscles has decreased substantially. Blood sugar begins to rise more than it would if you had remained standing or walking. The pancreas responds by producing more insulin, and this pattern, repeated many times throughout the day, every day, begins to drive the cellular changes associated with insulin resistance. This is one of the most important and least understood facts about prolonged sitting. It is not just that you are burning fewer calories. It is that you are fundamentally changing the way your cells respond to insulin, the hormone that regulates blood sugar, fat storage, and a dozen other metabolic processes. Studies measuring insulin sensitivity in people who sit for extended periods find measurable deterioration after just one day of prolonged sitting compared to days with regular movement breaks. The cells are not being lazy. They are responding rationally to the signal they are receiving, which is that movement has stopped, and therefore the machinery for rapid glucose uptake is no longer needed. The problem is that in a world where food is constantly available and glucose is constantly entering the blood, that signal is deeply counterproductive. The cardiovascular system begins responding to prolonged sitting within the first hour in ways that are equally direct and equally serious. Blood flow through the large vessels of the legs depends significantly on the pumping action of the calf muscles. The calves are sometimes called the second heart because their rhythmic contractions during walking compress the veins in the lower leg and push blood upward against gravity back toward the heart and lungs. When you sit, the calves go still. This pumping action stops. Blood begins to pool in the veins of the lower legs. Flow velocity through the major leg veins slows dramatically. Studies measuring blood flow in the femoral artery, the large vessel supplying the leg, have found that just 1 hour of uninterrupted sitting produces a 30 to 50% reduction in flow velocity. The blood is moving, but it is moving sluggishly, and that sluggishness creates conditions that the cardiovascular system was never designed to tolerate for extended periods. The practical consequences of this reduced flow begin to accumulate almost immediately. The endothelial cells that line the inside of blood vessels are extraordinarily sensitive to the mechanical forces of blood flow. When blood moves briskly past them, it creates a shear force that stimulates these cells to produce nitric oxide, a molecule that keeps the vessels relaxed, flexible, and resistant to the buildup of inflammatory plaques. When flow slows, shear force decreases, nitric oxide production drops, and the endothelial cells begin shifting toward a state that is more prone to inflammation and more receptive to the adhesion of the particles that contribute to atherosclerosis. After a few hours of sitting, this endothelial response is already underway. After years of daily prolonged sitting, the cumulative effect on arterial health is substantial and measurable. The arteries of habitual sitters show reduced flexibility, impaired endothelial function, and greater susceptibility to cardiovascular disease than those of people who move regularly throughout the day, even when other lifestyle factors are controlled for. The blood pooling in the lower extremities also creates conditions favorable to the development of deep vein thrombosis, the formation of blood clots in the deep veins of the leg. This is why long-haul flights carry a known clot risk. But long-haul flights are simply a compressed version of what many office workers do every single workday. The combination of reduced flow velocity, increased blood viscosity from the shift in posture, and the mechanical pressure of the seat on the back of the thighs, compressing the vessels there, creates a confluence of factors that nudge the blood toward clotting. For most people on most days, the body manages this risk without incident. But in people with additional risk factors, and in the context of a lifestyle where this pattern repeats day after day for years, the cumulative clot risk is far from negligible. While the cardiovascular and metabolic changes are underway, something is happening in the spine that deserves its own careful attention, because it is the source of some of the most common and most disabling consequences of prolonged sitting. The spine is a magnificent piece of biological engineering, an articulated column of bones and cartilage and ligament and muscle designed to bear load, transfer force, and maintain posture across a nearly infinite variety of positions and movements. But it is designed for dynamic loading, for the shifting, variable, multidirectional forces that come from moving through the world. What it is not designed for is static loading, the unvarying, unrelenting compressive force of sitting in the same position for hours at a time. When you sit, and particularly when you sit with the inevitable forward lean that screens and keyboards and the fatigue of holding upright posture naturally produce, the lumbar spine loses its natural inward curve and begins to flex forward. This flexion position dramatically increases the pressure inside the intervertebral discs, the gel-filled cushions between the vertebrae that absorb shock and allow movement. Research using pressure-measuring devices inside live spinal discs has found that sitting in a slouched forward posture generates disc pressure approximately 2 to 3 times greater than lying down, and significantly greater than standing. This sustained high pressure gradually compresses the discs, squeezing fluid out of them, reducing their height, and over time, compromising their structural integrity. The slow, progressive disc degeneration that produces the chronic lower back pain epidemic in modern society is not primarily a disease of aging. It is primarily a disease of sustained compression in a position the spine was never designed to hold for hours at a time.
The muscles surrounding the spine tell a parallel story. The deep spinal stabilizers, small intrinsic muscles that maintain the precise moment-to-moment positioning of each vertebra, are meant to be continuously active during upright posture, but they fatigue under the static demands of sitting, particularly as the hours accumulate and they progressively disengage. As they disengage, the larger surface muscles take over in a compensation pattern that generates tension and trigger points in the upper back, the neck, and the shoulders. The muscle tension headaches, the burning between the shoulder blades, the persistent neck tightness that millions of desk workers treat as an inevitable occupational hazard are in large part the consequence of a muscular system trying to maintain postural demands it was never designed to hold statically for this long. The hip flexors deserve specific attention because what happens to them in chronic sitters has consequences that extend far beyond the hip itself. The hip flexors are a group of muscles, primarily the iliopsoas, that run from the lumbar spine through the pelvis to the top of the femur. Their function is to flex the hip, bringing the thigh toward the torso, which they do constantly during walking and running. In a seated position, the hip is held in a state of continuous flexion. The hip flexors are effectively shortened and contracted for the entire duration of sitting. Over weeks and months and years of prolonged daily sitting, these muscles adapt to their shortened position. They become tight, less elastic, and structurally shortened in a process called adaptive shortening. And when that person stands up and tries to walk, the shortened hip flexors pull the pelvis into an anterior tilt, exaggerating the lumbar curve, compressing the lower back, and producing the distinctive forward-leaning posture and waddling gait that is increasingly common in habitual sitters. The lower back pain this generates is real and structural, but its origin is not in the back. It is in the hip, in muscles that have been held short for so long that they have forgotten how to lengthen. The glutes, which are the largest and most powerful muscles in the body and are designed to be the primary drivers of upright posture, walking, and hip extension, experience something similar but in the opposite direction. Under sustained sitting, the glutes are essentially switched off. They are in a lengthened, passive state with no demand placed on them. And over time, in a phenomenon sometimes called gluteal amnesia, they become progressively less capable of activating properly, even when called upon. The person who has been sitting for years and then tries to run, climb stairs, or recover from a stumble finds that their gluteal system does not respond the way it should. The stabilization and propulsion that should come from the glutes is being compensated for by the hamstrings, the lower back, and the knees, none of which were designed for that role, and all of which begin generating their own pain and dysfunction as a result. Moving upward through the body, the thoracic spine, the mid-back region, develops its own specific pattern of dysfunction in chronic sitters. The thoracic spine is designed to have a modest outward curve, but it is designed to move through a range of positions throughout the day. In prolonged sitting, particularly with the forward lean of screen work, the thoracic spine becomes fixed in an exaggerated outward curve, a posture called thoracic kyphosis, and the tissues surrounding it, the ligaments, joint capsules, and deep muscles, adapt to this position over time, becoming resistant to extension. The loss of thoracic mobility that results from years of sitting is one of the primary reasons that older adults lose the ability to stand fully upright, to reach overhead comfortably, and to rotate through the spine. It is commonly attributed to aging, but it is more accurately attributed to the accumulated postural history of years spent in a chair. The neck and shoulders complete the postural chain with their own characteristic dysfunction. The head, which weighs approximately 10 to 12 pounds in neutral alignment, effectively multiplies its load on the cervical spine with every degree it moves forward.
At a 30-degree forward tilt, common during phone and screen use, the effective load on the neck increases to approximately 40 pounds. At 60 degrees, it reaches 60 pounds or more. The cervical vertebrae, the discs between them, and the muscles holding the head up are bearing loads they were never designed to sustain for the durations that modern screen habits demand. The resulting cervical disc compression, muscle fatigue, and nerve irritation produce symptoms that range from headaches and neck pain to numbness and tingling in the arms and hands, a pattern so common it has acquired its own name in clinical practice. The lymphatic system is another casualty of prolonged sitting that receives almost no attention in popular health discussions. Unlike the cardiovascular system, which has the heart as a dedicated pump, the lymphatic system has no pump of its own. It moves lymph, the fluid that carries immune cells, removes cellular waste, and transports fats absorbed from the digestive system, entirely through the mechanical pressure of muscle contractions and body movement. When the body sits still for extended periods, lymphatic flow slows dramatically. Fluid begins to accumulate in the tissues, particularly in the lower extremities. The mild puffiness around the ankles that many people notice at the end of a long sitting day is lymphatic fluid that was not adequately circulated. But the consequences go deeper than cosmetic swelling. Stagnant lymphatic flow means slower immune surveillance, less efficient removal of inflammatory mediators from the tissues, and reduced capacity to respond to cellular damage and infection. The immune system of a habitual sitter is operating with a compromised logistics network, and the effects on systemic inflammation are real and measurable.
The brain is not exempt from the consequences of prolonged sitting, and the mechanisms are more direct than most people expect. Cerebral blood flow, the rate at which blood is delivered to the brain, is partly regulated by the activity of the leg muscles. Research published in the journal Physiological Reports found that prolonged sitting significantly reduced cerebral blood flow compared to conditions involving regular walking breaks. The brain, like all tissues, depends on blood flow for oxygen and glucose delivery and for the removal of the metabolic waste products that accumulate during neural activity. Reduced cerebral blood flow during prolonged sitting contributes to the cognitive fogginess, reduced concentration, and mental fatigue that desk workers routinely experience as the afternoon progresses. It also contributes to something more concerning over the long term. Regular physical movement stimulates the production of brain-derived neurotrophic factor, the protein that promotes neuronal growth, strengthens synaptic connections, and supports cognitive resilience. Sedentary behavior suppresses this production. Studies comparing sedentary adults to regularly active adults find consistent differences in hippocampal volume, the brain region central to memory and learning, with sedentary individuals showing greater age-related shrinkage. The brain literally changes its physical structure in response to how much the body moves. The metabolic and hormonal picture of chronic sitting extends into the fat tissue in ways that are specific and important. Lipoprotein lipase, an enzyme found in the walls of blood vessels in muscle tissue, is responsible for extracting fat from the bloodstream and making it available for burning as fuel. This enzyme is activated by muscle contraction. When muscles are still, lipoprotein lipase activity drops sharply. Fat that would have otherwise been drawn out of the blood and burned by working muscle tissue remains in circulation, eventually being directed towards storage. This is not simply a calorie math problem. It is an enzymatic and hormonal shift that makes the body metabolically more inclined to store fat and less inclined to burn it, independent of how much you ate or whether you exercised this morning. The extended hours of sitting between and after exercise are metabolically active in their own right, and their activity points in exactly the wrong direction. The research on all-cause mortality and prolonged sitting is some of the most sobering in the field of lifestyle medicine, and it contains a finding that shocks most people when they encounter it.
Studies following large populations over many years have found that prolonged daily sitting is associated with significantly increased risk of cardiovascular disease, type 2 diabetes, certain cancers, and all-cause mortality, and that this association holds even after accounting for regular exercise. People who exercise for 30 or 60 minutes in the morning and then sit for 10 hours are not protected from the metabolic and cardiovascular consequences of that sitting by their workout. The exercise is beneficial, but it does not cancel the damage of the prolonged sitting. The biology of sedentary hours and the biology of active hours appear to operate through partially independent mechanisms, and you cannot bank enough activity in one part of the day to fully offset what happens in the other parts. This finding has been described by some researchers as the active couch potato paradox, and it fundamentally reframes the question of physical health from how often do you exercise to how much of your waking time is spent in uninterrupted stillness. The good news is the mirror image of everything described here. The body responds to movement with the same speed and specificity with which it responds to stillness. Breaking up sitting with even brief periods of standing or walking, as short as 2 to 5 minutes every 30 to 60 minutes, has been shown to meaningfully restore blood flow, restart lipoprotein lipase activity, reduce postprandial blood sugar spikes, improve endothelial function, and interrupt the postural loading patterns that drive spinal dysfunction. The body does not require heroic effort to begin reversing the consequences of prolonged sitting. It requires frequency, small movements distributed throughout the day, activating the muscles and the cardiovascular system and the lymphatic network at regular intervals, signal to every system in the body that the organism is alive and mobile, and the machinery should keep running at full capacity. The chair is not going away. The desk is not going away. The screens and the meetings and the commutes and the long evenings on the couch are not going away. But the understanding of what they do to the body, absorbed fully rather than filed away as vague health advice, changes the relationship with stillness in a way that makes movement feel less like an obligation and more like a biological necessity. Because that is exactly what it is. Not exercise, not fitness, just movement. Regular, distributed, sufficient movement. The thing your body has been asking for all along in the language of a sore back and foggy afternoon and tired legs that you probably thought meant something else entirely.